is a sheet that I made last year when I realized it would be helpful to have just kind of a summary page of what are the 3 main situations that you might see in a free body diagram, and then also a list, again, just kind of a reference point for you of what are the forces that we're looking at and what does that mean. So on the right-hand side right here, that's my mistake. You're going to need to switch that. So right now, cross that off on your sheet and change it to normal, because that should be the gravitational force, then the normal force, then the frictional force, and I accidentally wrote friction twice. So fix that. Okay, so under each one of those forces where it says types of forces, you are going to, not right now, but at some point you'll want to do this, so maybe over the weekend, you'll want to write down a quick note about what are those forces. So what does that mean in which situation? So like tensional force, you might write down, well, this is a force when something is hanging from a rope or a chain or a cable. So each one of these has what the force is, the variable, how you abbreviate, how you write it, and then you are going to write down, you're going to look back through either the front page of this worksheet or look through your notes yesterday and write down what are these forces, where do they come from, or where might you see them. So you'll want to make sure to do that sometime in the next couple of days, because if you don't, well, then this isn't a very useful summary sheet if you don't put anything down on it. Here's what's on the other side. These are the 3 main situations we're going to see with free body diagrams. The first one is when an object is on a surface. So something like my textbook sitting on the table over here. Object on a surface, gravity is working on it, and then the table or the floor or the stool or whatever the surface is exerting an upward force. Often, most of the time, unless the book is crashing through the table or flinging up into the sky, the normal force and the gravitational force are going to be balanced. You may also have, depending on what other kind of motion is going on, you may also have an applied force and a frictional force. So if you've got something on a surface and you've got an applied force, you're pushing it across that surface, that's an applied force. Friction then is always working in the opposite direction as motion. If those two are balanced, the way they are drawn here, well then you have your net force is 0 because your forces are balanced. Your acceleration is 0, so either you're pushing on it and it's not going anywhere, or you're pushing on it and it's moving at a constant velocity because the acceleration is 0 because the net force is 0. Other variations you might see of this are if you have a greater applied force than a frictional force, then you'd be accelerating toward the right. What if you have no applied force and you just have friction? Well, then you'd be slowing down in whichever direction. These might be flip-flopped on each side, depending on if you're going to the right or to the left. Next, like main scenario you're going to see is something hanging. If something's hanging from a chain or a rope or a cable, it's going to have a tensional force. Still gravity. If these two are equal and opposite, then you will see no motion or constant velocity because if they're balanced, net force is 0, acceleration is 0. Or if your gravitational force is greater than your tensional force, well then it's accelerating downward. If your tensional force is greater than your gravitational force, then it's accelerating upward. Last one is if we have a falling object. This particular example includes air resistance. So we can say, hey, maybe this is a parachuter. This particular example, gravity matches air resistance. So that means that if they are falling, they're falling at a constant velocity. If gravity were greater than air resistance, then they'd be accelerating downward. If air resistance were greater than gravity, then they would be accelerating upward, which means that as they travel down, they're slowing down. If you take that away, if you take away the air resistance and you ignore air resistance, either because there is a situation where you can reasonably ignore air resistance, like maybe we put it in a vacuum and we take out all the air. Or maybe we have situations like something like a ball where the air resistance is negligible, meaning the air resistance is so little that it's not going to be a big deal. Then that would be in true free fall. So true free fall is when gravity is the only force that's acting on it. So keep this as a reference sheet. Make sure you do make a quick note about what each of these types of forces are. Okay, when you're doing a PhET, what I'm always going to have you do first is just play with it. So that's what you're going to spend the first 10 or so minutes doing. But first we need to get onto PhET. It's this app the black background, the one that you downloaded just the other day, and you'll need to scroll down until you find forces in motion right here. So click on that. When you're playing, you can click on any one of these things and play through there. But the one that we're going to use, so the one that I do want you to play the most with, is net force. So once you have this open, you'll see that it's kind of a tug of war sort of setup. The different sized people represent different forces. I want you to turn on some of these things in the upper right corner up here. So turn on sum of forces, that will give you the net force. Values gives you the actual magnitude of those forces. And speed gives you a little speedometer, which is useful because if you have a net force, you're going to see acceleration. And that acceleration you'll see because the speed will be getting faster or slower depending on what direction your motion is and what direction your net force and acceleration is. Acceleration, remember, means change in velocity. So as long as we see that speed changing, then that will be acceleration. So let's set up something here. I want to show you a couple things, and then you will have time just to play, and then you'll need to work through the actual PhET activity. So right now, our forces are balanced. So our net force is 0, our acceleration is 0. So if I click go, nothing's going to happen. Net force is 0, acceleration is 0, so no motion is going to happen. What if I'll put another blue guy up there. Now my net force is toward the left. So when I click go, I'm going to see acceleration toward the left, and you can see the speedometer is climbing up, showing it's getting faster, it's accelerating. Okay, let's reset that. I want to try something else. What if I start it like this, where my net force is toward the left, so I'm going to see acceleration toward the left. Then what if I take away one of those blue guys right here after it has started moving? If I do that after it started moving, the net force will be 0, which means the acceleration will be 0. If the acceleration is 0, what's going to happen to the speed? So let's try that. So let's go. It's accelerating toward the left. Take that guy away. Now the net force is 0, and watch that speedometer. The speedometer now is staying constant. Because even though it was already moving, when the acceleration, the net force and the acceleration are 0, then it stays at a constant speed because the acceleration is 0, which means there's no change in velocity. All right, so you'll need to play with this. Go ahead and play for a good 10 minutes or so. Just try things out. See what happens. Can you start taking away guys and add other guys and change the acceleration in the other direction? Play with it. Try stuff out. After you've played with it for a good 10 or 15 minutes, then you'll need to look at the actual packet and start working through that activity in the order they have it, setting up these different scenarios, asking the questions. Make sure you check your Canvas page because day 32 is Monday for the B group and Tuesday for the A group. You do have 2 assignments on there. One of them is to finish this PhET. The other one is to read an article. So make sure you do that, do what you need to do when you need to do it, and turn everything in.